So look at the diagram here. So site ID 1, like controllers here, and there is one headquarter, site ID 100, branch 1, site ID 101, another branch, site ID 102, right? And there are two different transports, MPLS and internet. uh, V is the branch WAN edge device here, VS1, VS2 and VS3, right? Controllers, so there are three different controllers here. Just here, like I'm just going to give you a high level overview of three controllers. We will just discuss vSmart, vBond, vManage in detail, right? So rest assured, we will discuss like vSmart, vBond, and vManage in detail. Just for now, just to understand like this basic, like at least what I want, that you should have basic understanding of SD-WAN, right? So just introduction. So vManage, this one is what? Management server. vSmart is the control plane, unified or central control plane. And vBond is the orchestrator. In fact, it's like a kind of glue in between like controllers and the WAN edge devices. First point of contact, of course, authentication. First, like WAN edge devices, they authenticate with the vBond, right? So just skip this vBond for now. So here, like there are different controllers, headquarter, two different sites, MPLS and internet, two different transport. So now V is one, like LAN site prefixes are 172.16.1.0, 2.0, right? V is one, this one, branch one is router, will not advertise prefixes directly with VS2 or headquarter device. No, right? They do not exchange routing information directly with each other. Rather, branch 1 is router will establish peering with vSmart, and here like this, for this peering there is one protocol, and I'll discuss this OMP protocol, overlay management protocol. Is similar to IBGP sort of thing, but not exactly IBGP. And why this OMP? Why not BGP or any other protocol? Why a special or a new protocol like OMP is used here? So I'll explain that, right? Just for now, like you should understand, it's a protocol used in SD-WAN, and the role of this protocol is to advertise prefixes, policy, and configuration, and a lot more. In fact, it does a lot of things. So basically, V is one router. This will advertise prefixes either directly connected or maybe received from any IGP or any other like BGP or OSPF or any other protocol, right? Not directly to another branch router or headquarter router. No, to the vSmart, the control plane device. And then this control plane vSmart will advertise prefixes received from VS1 to VS3, and of course this one VS2, right? If like there is some policy, then maybe this vSmart can change the attribute of the prefix. In fact, there is no policy, then without doing any modification, without changing anything, prefixes will be advertised with all other WAN edge devices. So my point here is WAN edge devices, they do not exchange routing information directly with each other, right? Here, like this one, vSmart, the control plane device, right? Control plane device here plays very important role here. Devices, they exchange their prefixes from like with the help of vSmart. They do not exchange routing information directly with each other. And once it is done, like the prefixes are exchanged, are advertised. Then for data plane, yes, now they will have direct reachability. Basically, technically, it's a IP secternal. IP secternal is negotiated between managed devices, right? So basically, in SD-WAN devices, WAN devices, they do not exchange routing database directly with each other. Prefixes are never exchanged directly with each other, right? From vSmart. So vSmart plays very important role in control plane exchange, routing or data exchange, maybe policy or some other information, but not in data plane, right? It means VS1 will communicate directly with VS2, but data routing prefixes, yes, via this vSmart. And even like this control plane exchange and even data plane exchange, both are secure, right? Because routing protocol, control plane protocol, OMP basically, OMP enabled by default, and it runs inside a secure tunnel, and the tunnel here is either DTLS or TLS, right? Or TCP based or UDP based, transport layer security. And even for data plane security, there is IPsec tunnel. For control plane security, DTLS or TLS tunnel. So basically, in SD-WAN, secure control plane and secure data plane. And do we need to do something? No, right? It is done automatically. OMP is enabled by default. Even like this LAN side or service side, like prefixes received from OSP of intra-area, OSP of inter-area, locally connected or static routes are even advertised into OMP by default. I mean, like they are redistributed into OMP by default. We don't need to do anything. Yes, if like there is OSP of external route or BGP route, then for that, yes, we have to configure redistribution. But for OSP of intra-area or inter-area, even redistribution is not required here. We don't need to configure anything. I mean, like this VS1 router will do advertisement automatically. It means prefixes received from here, like from this LAN side router, maybe with the OSPF or any other routing protocol, will be redistributed into OMP. So one-way redistribution is done automatically, right? But OMP routes are not redistributed automatically into the IGP or any BGP protocol, right? For that, yes, we have to configure. So DTLS or TLS tunnel established automatically. OMP is enabled by default. It runs inside the DTLS, a secure channel, IPsec tunnel, established automatically. We don't need to do anything. And if you are aware with like I phase 1, I phase 2, I mean like the session keys and all that. So when we do this IP6 side to side VPN sort of thing and like Cisco routers or any firewalls, then we do a lot of configuration. Like first we configure I phase 1 parameters or attribute, then I phase 2 parameters, and then like this IP6 tunnel is established. Here in SD-WAN, you don't need to do anything, right? Session keys even are distributed by this vSmart. It is done automatically. And even there is another protocol, BFD, bidirectional forwarding detection protocol. It is enabled by default, and even you cannot disable this BFD protocol, and it runs inside IPsec tunnel, a secure data plane tunnel, right? OMP inside GTLS or TLS tunnel. So in SD-WAN, complete there is secure data plane and as well as secure control plane. So in spite of being decoupled, I mean like the data plane and forwarding management plane decoupled, but still there is a secure communication. Security wise, you don't need to worry about that. Complete secure channel, right? And what about the transport underlay network like MPLS or maybe here internet? So control plane or management plane forwarding plane, that is data plane, they all are not in the same chassis. As I said earlier, in Cisco 6500 or 4500 catalyst switches, even if like there is a separate line card, I mean like the input output or forwarding plane or data plane and control plane, so at hardware level like they both are completely separated, but still they are in the same chassis, right? Back plane and connected. Here forwarding plane is completely separated, in fact decoupled. And what's the transport here? MPLS or maybe the internet. And do we need to worry with the transport? No, not at all. It's underlay network. OMP is like the overlay routing protocol. Overlay OMP. So and what about the configuration of like WAN edge devices? Maybe like initial configuration, some initial configuration. Why initial configuration? Like because in case if like they do not support GTP or PNP, like zero touch provisioning or plug and play. So what we do, like we run some like command or configuration to the WAN edge devices to ensure reachability to the controller, because WAN edge devices should be able to reach the controller, right? And I mean like there should be IP reachability either by using MPLS transport or internet transport. That is by using one transport, like there should be this should have IP reachability to the controller, right? So minimum configuration is required here. Only minimum configuration. Once successfully WAN edge devices, they have joined to the controller, they have registered themselves to the controller. Then after, you don't need to do anything here. And even you cannot do anything, you cannot I mean like you can run the show command and all the commands here, but if you want to change the configuration locally, you have logged in here either via management port, or let's say directly you have SSH to the device, you want to change the configuration from the CLI, you cannot do that, right? Because here in SD-WAN, Cisco SD-WAN, devices can be either managed locally, CLI based, or we manage. We cannot do both. Like I mean, like if devices are managed from this we manage, so we cannot change the configuration from CLI. Practically, at the time of like doing anything from the CLI, you will not receive any error message. But once you have done with the configuration and you want to like commit the changes, then in fact there will be an error message that device is vmanaged, so you cannot do anything locally here, right? So because in some other solution you must have seen that we have the flexibility, like even like some configuration we can push from the controller, from the management server, and even like we are also allowed to do configuration or config change locally also, device itself. But here in SD-WAN, Cisco SD-WAN, no, you're not allowed to do that, right? Either just do it locally, I mean like the CLI base, or just push the configuration from the vmanage. So you understand uh, like how is all done here in SD-WAN. And even like let's say you want to change path selection, or maybe route filtering or something like related to the control plane exchange. Because in MP sorry SD-WAN solution, SD-WAN by default there is full mesh topology. So even if there is a headquarter and there are two branches, right? But branch one will not first route packet to headquarter and then from headquarter to another branch after. No, right? Directly they will talk to each other. They will have IPsec tunnel established directly with each other, right? By default. If we want to change that, we want to change the topology from full mesh to hub and spoke. Yes, we can do that. And do I need to do it locally on the WAN edge devices? No. So from where? From here, from the management server, right? From here only, we will create the policy, and then policy is pushed to the vSmart here, and then it depends like what kind of policy we have created. Some policies are further pushed to the WAN edge devices by this vSmart. I'm talking about the centralized policy, and some policies they are never pushed to the WAN edge devices. They will remain to the controller only here. So controller, this vSmart will keep that policy locally here. And of course, like um, uh, that it depends like what kind of policy that is. Accordingly, in fact, if some manipulation or attribute change or something like setting a preference value of the path is required, then vSmart will do that, right? Even route filtering or something. We will see that like policies and all that. So let's not get into in fact policy and all that. But here like you can understand that if in case if we want to change the topology from the full mesh to hub and spoke, or maybe we want that VS1 router should prefer MPLS over internet, because by default in SD-WAN there is ECMP, equal cost multipath. But if we want that VS1 should prefer MPLS over the internet, yes, can be done very easily, right? And without touching any WAN edge device. So from where? From the management server, we'll create the policy like then this vSmart, we will push the policy to the vSmart, and then vSmart will do the rest. We'll change the preference value, because here in OMP also preference is used for the best path selection. So by default there is no preference value set, and if with the policy we set the preference of this MPLS transport to let's say 100 higher value, then definitely VS1 will prefer MPLS as the transport. Even if we want to configure application aware routing, right, in conjunction of performance, like the performance based routing sort of thing, here it is known as the service level agreement. And service level agreement means three components, three attributes, right? Jitter, delay, and loss, packet loss. So it can be done very easily, right? We can configure application aware routing, keeping like three attributes in mind. I mean like we can configure like routing in such a way that this VS1 router should prefer internet transport for chat based applications and some messenger services, but as long values specified here in service level agreement like jitter, delay, and loss are in fact meeting up. I mean like if we have configured here like the delay one side delay is not more than let's say 40 ms, and here delay is let's say 60 or 70 ms, so definitely internet transport will not be used, right? So configuring application aware routing, taking like this service level agreement into account or consideration is very easy. It's something that would affect the data traffic, right? Data traffic. But again, we will create this kind of policy from here only, from the vManage. But we don't do anything. We don't create any policy. We don't change like the topology. Then by default, full mesh topology and full mesh topology and ECMP, right? Understood? Equal cost multipath. So if there are two transports, both transports will be used. So you'll find both transport in the routing table here, right? And full mesh topology. But if we want to change the like topology from full mesh to hub and spoke, or from ECMP to maybe like application aware routing, or setting up preference value of one of the transport, yes, can be very easily done here in SD-WAN solution, right? In SD-WAN solution. And I'm just coming to traditional WAN solution also, so that you can understand side by side. Was that also possible in traditional network? I mean, like configuring application aware routing or something, or not? And if yes, then how it was done in fact there. Another important point I must mention here before just I move on to the next slide, and that is here in SD-WAN solution for network segmentation. Here in SD-WAN there is concept of VPN, virtual private network. So VPN concept in SD-WAN is used for network segmentation, right? Network segmentation is similar to VRF, virtual routing and forwarding in the traditional network. So VRF is what? For what purpose VRF is used? For routing table virtualization. So if we want to virtualize routing table, so what we do, we create VRFs. We want to use overlapping IPs, then what we do, VRFs. Like multi-tenancy by the service provider, again VRFs. Strict isolation of like routes, VRF. It means in nutshell, VRFs are used for network segmentation. So very similar to VRF, here in SD-WAN, what we use, VPN, virtual private network. So VPN is used for network segmentation. And another important point I missed out, as I said earlier, like when we configure application aware routing in SD-WAN, it means we create policy in such a way that for one application or set of applications or services, one transport should be used, and for other application another transport, and taking like this service level agreement into account into consideration, right? And there are three attributes or values when we configure create service level agreement, like loss, packet loss, delay, and jitter. And but how it is computed, how it is calculated? I mean, like, do we need to configure any additional protocol for that to collect the matrix, like the packet loss or delay? No. Why? BFD. It is used to check the liveliness and as well as collecting matrix, right? And we don't need to configure this bidirectional forwarding detection protocol. You must be aware with this BFD, right? We also use BFD in traditional networking, and in conjunction of even routing protocol. Very quickly, let me give a very basic idea about this BFD. So in traditional network, what we do, like let's say the routing protocol here is OSPF, right? OSPF is the routing protocol configured on both the routers R1 and R2. So as we understand, like OSPF is like the routers, like on the common segment, they establish urgency, like the neighborship with each other, and for that, in fact, they exchange hello packets, and this packet has like area ID, router ID, and different timers like data interval timers, and priority, neighbor address. In case of like a broadcast network or NBMA, like the DR and BDR IP address, right? Uh, Stuff flag, authentication type, and code or data is all there in the hello packet, right? Some values should be identical, and of course router ID and some other values should be unique. And this packet is exchanged periodically in every 10 seconds, and 40 seconds is what? Dead interval. So what if like there is no hello packet from the neighbor, or maybe like mismatched parameters? So this neighborship comes to an end, right? So in order to speed up the convergence, what we can do, we can minimize this interval from 10 seconds to maybe 1 second, right? But it's very CPU intensive process. So if you decrease the interval from 10 to 1 second, I mean like in every 1 second, both router will exchange hello message, right? Because this timer should also be same on both the routers. Why? Just to speed up the routing convergence. So if you do that, we minimize this interval. So this can affect CPU utilization. So instead of doing that, what we do, we enable BFD protocol, right? It's just one of the use case, BFD. Similar to like UDLD protocol, unidirectional link detection protocol. So BFD protocol. So again, like BFD is similar to UDLD sort of thing, like a kind of like echo message is like exchange between both the routers. But here interval is like, let's say 300 ms or something, and multiplier value is 3. So what will happen? In every 300 ms, BFD messages will be exchanged, right? And if 3 messages in a row are missed out, no BFD message received from the neighbor, then this link will be assumed either like unidirectional or maybe down. And then BFD will report the same to whom? OSP protocol. BFD will tell the OSPF that I haven't received BFD message from the neighbor, right? This means link is not operational anymore. So what OSPF will do? OSPF will do a very quick convergence here. So instead of minimizing OSPF hello interval, what is recommended? You should enable BFD, and BFD, if it is integrated with the OSPF, then BFD will report to the OSPF that there is some issue with the link, right? Don't wait for 40 seconds, because here is still OSPF intervals. Dead interval is what? 40 seconds. So OSPF will not wait for 40 seconds now. The moment VFD just intimate or inform OSPF that there is some issue with the link, physical link, physical link is using unidirectional, not bidirectional, or there is some other issue, BFD will OSPF will do rest, like I mean like will converge immediately. So in order to speed up the convergence without compromising like the device performance, without increasing CPU, because like generating a, in fact, OSPF hello packet in every 1 second is really CPU intensive, because hello packet means like too many values there, too many parameters, area ID, router ID, stuff flag, authentication code, authentication time. You understand that? And BFD is very small message, a small packet. So we have already like seen like in the past like the use of BFD. Same protocol is working here, and one role of BFD is same, like checking the path liveliness. But apart from that, also matrix, collecting matrix, right? And really very important when we configure application aware routing, when we create service level agreement, and it's all done automatically. A very good feature, right? Okay, so I'm going back to the next slide, and let me finish that. Then again, we will be back here, and I will also show you the dashboard of vManage, and with the same topology, what I'm showing you here, right? Devices, of course, pre-configured, because just for the demonstration purpose. Whenever we will start doing lab, then I will start from the scratch from the very beginning. What we'll do, we'll just first like we will put the devices in the topology, and first we will do the initial configuration of controllers. We will learn like how to initialize the controllers, how to configure certificate authority server, and then extending network, like maybe 2 or 3 branches and headquarter, and then resting managed devices to the controller, creating template policy and all that. So rest assured, we will start from the scratch from the very beginning. It's just for the demonstration purpose only. My objective is like to just make you understand SD-WAN. What is SD-WAN? So in this section, My objective is just to explain benefits of SD-WAN. You should properly understand what is software-defined WAN and why SD-WAN. Why not traditional WAN, traditional wide area network? So that's what my objective is, right? My objective is not explaining how to configure controllers, how WAN devices will get themselves registered to the controllers, or even how to create template or policy and all the stuff. No, that's not my objective, at least in this section. We'll do that, but later on in this section, my objective is very clear, and that is just you should have understanding why SD-WAN, right? And of course, since we are doing like Cisco SD-WAN, then I'll be talking only Cisco SD-WAN. I mean VIPTELA, basically VIPTELA has been now merged to the Cisco, so Cisco SD-WAN. Because there are some other big players like apart from the Cisco VIPTELA, like Versa, Silver Peak, Velo Cloud, even FortiGate, and many more in fact. But I will talk about Cisco only, Cisco SD-WAN solution. So it's all like we manage, we here like stand for VIPTELA. So now it's part of Cisco. So we like here we this WAN is also V edge. Cisco edge device is like C is, not the V. Alright, so I'm now back to the slide here.